Welcome dear students. This is our next problem having once again been chosen from the same book, Modern Physics by Kenneth S. Crane. As usual, we first come to its statement. Okay, a certain crystal is cut so that the rows of atoms on its surface are separated by a distance of 0.352 nanometer. A beam of electrons is accelerated through a potential difference of 175 volt and is incident normally on the surface. If all possible diffraction orders could be observed, at what angles relative to the incident beam would the diffracted beams be found? Okay, dear students, its statement is lengthy, but problem is not so harder. So as usual, we first come to its helping tools. Dear students, first tool has been taken in our videos, in our problems many times, and we will take it so long as we need this tool. Okay, so first tool is momentum of a photon. P is equal to E over C, where E is photon energy and C is the speed of light in vacuum. This alternatively becomes equal to hf over C, where h is Planck's constant and f is frequency, and this alternatively becomes equal to h over lambda, where lambda is the wavelength. Okay, now we come to second tool. This tool has once again been shown so many times that there is no need almost to discuss this anymore. Okay, however, in this table, speed of light is relevant, Planck's constant h is relevant, which is given in two different systems of units. Electron mass is relevant, value of hc combined is also relevant. One atomic mass unit equal to 931.5 million electron volt over c square is relevant. Okay, now we move to third tool has also been taken many times. Okay, here value of electron in terms of mc square, that is 0.5 million electron volt or 511,000 electron volt is relevant. Okay, now we come towards tool number 4. Tool number 4 has been taken in two different versions. Okay, one and the same thing has been taken from two different books. Snapshot has been taken from two different books. Okay, diffraction grating. A diffraction grating consists of a large number of thin parallel slits spaced a distance d apart. The condition for maximum intensity in the interference pattern is the same as for the two source pattern, but the maxima for the grating are very sharp and narrow. That is, d sine theta is equal to m lambda, where m is equal to 0, plus minus 1, plus minus 2, plus minus 3, and so on. Okay, or in other words, the same material has been chosen from some other book. Okay, this snapshot says diffraction grating. A diffraction grating is a series of slits used to separate an incident wave into its component wavelengths by separating and displaying their diffraction maxima. Diffraction by n multiple slits results in maxima lines at angles theta such that d sine theta is equal to m lambda for m equal to 0, 1, 2 maxima, with the half width of the lines is given by delta theta hw is equal to lambda over nd cos theta half width. Anyhow, the main thing which we are concerned has been included. Okay, now X-ray diffraction. Okay, a crystal serves as a three-dimensional diffraction grating for X-rays with wavelengths of the same order of magnitude as the spacing between atoms in the crystal. For a set of crystal planes spaced a distance d apart, constructive interference occurs when the angles of incidence and scattering measured from the crystal planes are equal, and when the Bragg's condition is satisfied. 2d sine theta is equal to m lambda, where m is equal to 1, 2, 3 and so on. Or in other words, this snapshot has also been chosen from some other book. X-ray diffraction. The regular array of atoms in a crystal is a three-dimensional diffraction grating for short wavelength waves such as X-rays. For analysis purposes, the atoms can be visualized as being arranged in planes with characteristic interplanar spacing d. Diffraction maxima due to constructive interference occur if the incident direction of the wave measured from the surfaces of these planes and the wavelength lambda of radiation satisfy Bragg's law. Okay, that is 2d sine theta is equal to m lambda for m equal to 1, 2, 3 and so on. This is Bragg's law. Okay, anyhow, now we come to its solution. Okay, we can have two different equations in classical mechanics. Classical expression, kinetic energy is equal to half mv square and potential equal to mv. When we solve these two equations simultaneously, then we get the expression k equal to p square over 2m. Okay, this implies that p square becomes equal to 2mk. Okay, we have kept p square on one side. This implies that if we multiply both sides with c square, then this expression takes the form as p square c square equal to 2mc square k. This implies that p square c square is equal to 2 into m. In place of m, we have used the value which is included in two different tools which have been included in our earlier part of this problem. Okay, that is, in place of mc square, in place of mc square, we have taken 2 is same which was already in place of m, we have taken 0.511 million electron volt into 175 electron volt. This is given in this statement. Okay, 175 electron volt. Okay, this is 175 volt. Okay, this a beam of electrons is accelerated through a potential difference of 175 volt. Okay, so this value has been chosen from this statement. Okay, yes, this is in place of k, we have used this value 175 electron volt, and in place of mc square we have chosen this value from the tool or table. Rather, 2 or 3 tables have been introduced in our problem. Okay, this implies that p square c square become equal to this into this into. In the next step, what we have done, we have converted million electron volt into electron volt. Okay, million m stands for 10 raised to the power 6. So 0.511 will become 511000 electron volt. Okay, so now both quantities have been transferred into electron volt. Okay, so this implies that p square c square has become equal to 13,373.48 electron volt. Actually, dear students, P square C square has become equal to 178850000 electron volt square. Okay, now we will take under root on both sides. When we will take under root on both sides, then P square C square will be converted into simply PC, and electron volt square will become simply electron volt. Okay, because under root is power 1 by 2, and hence 2 will be cancelled with 1 by 2. Okay, and under root of this value, that is 178850000 will become 13,373.47 electron volt. Then this implies that value of momentum P is equal to C will be become in the denominator on other side of the equality, and hence we will get P equal to 13,373.48 electron volt over C. Or in other words, we can modify this expression and write it in the form P equal to 1.337348 into 10 to power 4 electron volt over C. Because, dear students, we have shifted decimal 4 stages behind. We have shifted decimal 4 stages back. So power of 10 will be plus positive. Okay. Now we move to next part of this problem. Also, P is equal to E over C is equal to HF over C is equal to H over lambda. Okay, this is the tool which we introduced top of the list at serial number 1. First tool in which momentum of photon was defined. Okay, so this implies that lambda becomes equal to H over P. Next, what we have done? We have done nothing. We have simply put values of these two parameters. Okay, H over P, value of Planck's constant H is also given in a table which we introduced as a helping tool for this purpose, while value of P is that which we have recently calculated in our previous step. Okay, so when it will be simplified, electron volt will be cancelled with the electron volt, and our answer will become in terms of speed of light C into S. So now in the next step, we are replacing C by its value in terms of meter per second. Okay, so we know that this value is also given in a helping tool in the table. Okay, 2.998 into 10 to power 8 meter per second. Okay, so here second will be cancelled with second, and our wavelength lambda will become only in terms of meter. Okay, so our wavelength has become equal to 9.26 into 10 to power minus 11 meter. Okay, dear students, as I have mentioned many times previously, that 10 to power minus 11 is not very much suitable for us. Okay, what is suitable for us is 10 to power minus 3, minus 9, or 10 to power minus 12, or 10 to power minus 15, or 10 to power minus 6, or 10 to power minus 18, or 10 to power minus 3. Okay, that is multiples of 1000. Multiples are divisors of 1000. Okay, so this becomes equal to 0.0926 into 10 to power minus 9 meter, and we know that 10 to power minus 9 is nano. So our wavelength lambda will become equal to 0.0926 nanometer. Okay, now we move to next part. Okay, we know that maxima for a diffraction grating occur at angles phi such that the path difference between adjacent rays d sin phi is equal to a whole number of wavelengths. Okay, in mathematical form, d sine phi is equal to n lambda, where n is equal to 1, 2, 3, so on. This is equation number 1, where n is the order number of the maximum. This implies that sine phi becomes equal to n lambda over d. Okay, when d shifted on other side of equality, it will become in the denominator. Okay, on left side it is in the denominator, but after being shifted on other side of equality, it will become in the denominator. Okay, dear students, actually here the wording used is slightly different from the philosophy described in our two tools for this problem. One tool was diffraction grating and other tool was X-ray diffraction. Okay, however, this wording to explain this equation is negligibly different from that. Okay, anyhow, it does not make very much difference. Okay, now sine phi has become equal to n lambda over d. This implies that phi will become equal to sine inverse n lambda over d. We have given equation number 2 to this expression. Okay, next we solve equation number 2 for n equal to 1, 2 and 3. Okay, when we will solve equation number 2 for n equal to 1 and then n equal to 2 and then n equal to 3, then this equation will take the form of equation number 3, 4 and 5. Okay, so for n equal to 1, phi 1 it becomes equal to sine inverse lambda over d. Okay, because here n is equal to 1, so 1 whether we write or not, it is equal. Okay, because 1 is always multiplied. So okay, however, for n equal to 2, phi 2 becomes equal to sine inverse 2 lambda over d, because here n is equal to 2. For n equal to 3, phi 3 becomes equal to sine inverse 3 lambda over d. Okay, question number 5. Dear students, here now question arises whether we are not taking value of n equal to 4. Okay, this fact will be disclosed soon at the end of this problem. Okay, that why we are taking only 3 values, n equal to 1, 2 and 3. We are not taking n equal to 4. Yes, students, actually at the end of this problem we will see that for n equal to 4, value of phi, that is sine inverse, becomes greater than 1. Okay, value of sine varies in between 1 and minus 1. Okay, it can never exceed 1. That is why if we take n equal to 4, our expectation becomes defective, false, value becomes greater than 1, while its maximum variation is from minus 1 to plus 1. Okay, so anyhow, now phi 1 is equal to sine inverse 0.0926 nanometer divided by 0.352 nanometer. Okay, dear students, one value, that is lambda, we have find out in a previous part of this problem, while other value is provided in the statement. Okay, both are nanometer, so nanometer will be cancelled with nanometer and we will be left with sine inverse 0.263, and when we will find its value, it will become 15.248 degree. Okay, dear students, this value is usually found from scientific calculator. In 1983-84, I was using, I very clearly remember, I was using FX82 calculator. Okay, in 1983, 84, 85, 86, 87, 88, I was using scientific calculator FX82. Okay. However, at this time I have no calculator, so I have found this value from internet. Okay, where mm, a, cal- a calculator is given in which we put the value and it immediately gives its answer. Okay, so it is quite a separate discussion, nothing kept in this. Okay, so phi 1 becomes equal to 15.248. Phi 2 becomes equal to sine inverse 0.526, and its value becomes 31.736 degree. Okay, dear students, we are seeing that value of phi increases as a multiples of 0.263. Okay, for phi 2 it has become equal to 0.536. For phi 3 it has become sine inverse 0.789, and its value has become equal to 52.092 degree. Okay, then definitely phi 4 will become 2 times 0.526, that is it will become 1052. That is 1052 will be written as 1.052. So it value increases from 1. So we will not take y4. Okay, so phi 3, only phi 3. So here in wording we can explain this value about y4. Okay, dear students, sine inverse 263. Okay, in phi 2 it becomes double, in phi 3 it becomes triple time, but in phi 4 when it becomes 4 times, it becomes 1.052, and value of sine varies in between -1 and 1, so it becomes out of our range. Okay, so this is the end of this problem, and this is the end of this video. Till next video, Allah Hafiz.